In this lesson, we'll learn about voltage and current, which should help us understand some of the phenomena we noticed in the previous lessons. We'll start off with an analogy. A battery is analogous to a water tank. The amount of water in it would basically represent the amount of charge left in the battery. When it is fully charged, you can compare that to the water tank being full, and as you start discharging, the water in the water tank gets lower, and then when it's fully discharged, you could think of the water tank as not having any water. So in this case, a simple circuit is basically a single connection to the water tank, and you're drawing water from that connection. So what happens when we connect multiple outlets to the same pipe? And that's analogous to a series circuit that we saw before. It's sharing the same current or the same quantity of water. And then if you have multiple connections to the water tank, that's analogous to a parallel circuit. As we saw before, different types of circuits have different implications on the voltage and current that is flowing through the circuit. So we'll look into that next. We'll start looking into what voltage and potential difference means. In the water tank analogy, the potential difference basically refers to the pressure of water that's coming out of the pipe. As you know, when the water tank is full of water, the pressure is going to be high, and when the water is pretty low, then the pressure is going to be low. So the pressure of the water from the outlet corresponds to the voltage, and the quantity of water that is coming out of the pipe, that corresponds to current. Getting an intuitive understanding of what voltage and current means is one of the primary objectives of this course. So I'll emphasize again, voltage can be thought of as the pressure of the water in the tank, and current could be thought of as the quantity of water that is flowing through the pipe. So with this in mind, how should we interpret the voltage and current passing through the different types of circuits? So in this case, let's start with a series circuit. Using the water tank analogy, we can see that there is a single pipe that is connecting to all the consumers or the LEDs, which means that the pressure is kind of shared between them. So there is going to be a drop in the pressure or the voltage. We call this an voltage drop. However, the current is going to be the same because the quantity of water is not changing. So in a series circuit, the voltage drops and the current stays constant. And this is the reason why we had to have multiple batteries in a series circuit to light up multiple LEDs, because the voltage across each LED is dropping. So by the time you get to the last LED, you don't have enough voltage to light them up. So there is no current flowing through them. In contrast, for a parallel circuit, the reverse is true. That is, the voltage would be the same, whereas the current would change. Going back to the water tank analogy, the pressure across each pipe is going to be the same, meaning constant voltage, whereas the current would be different depending on how much is being drawn out of the pipe. So that explains why when we had a series circuit, we had to have multiple batteries, and in a parallel circuit, we just need one battery to power all the LED. So does that mean a parallel circuit is better, that we need just a smaller power source to power multiple items? No, that is not true. The multiple LEDs drain the power from the battery much faster than in the series circuit. So there is still conservation of energy. Another small difference between a series and parallel circuit is that in a series circuit, you just need one wire running through all the LEDs, whereas in a parallel circuit, you need two wires connecting to each of the LED. So what that means is you need to have more connections. There's positives and negatives to both of these circuits. That is, in a series circuit, even if one light goes out, then the whole circuit is out. Whereas in a parallel circuit, you could have one of the LEDs go out, but still have connection to the rest of them, and the rest of them could light up. So if you understand the difference between series and parallel circuit and how voltage and current varies between them, we kind of accomplished the goal with this module. That's kind of the primary learning objective for this module. In the next lesson, we'll learn about switches, which we will then use in our fun project at the end.